Hello everyone, welcome to Try Right, the new era of learning. This is Pack 365. Today's module 2, we're discussing about depth first search DFS in algorithm in AI. Part A. Let's go into the topic. Depth first search DFS for artificial intelligence. So depth first search contributes to its effectiveness and optimization in artificial intelligence for algorithmic insights to real world implementations. DFS plays a huge role in optimizing AI systems. Let's dive into a fundamental of DFS, its significance in artificial intelligence and its particularly applications. Partially its applications. So what it means, so we can say that DFS contributes to effectiveness and optimization in AI, helping both in algorithm and real world systems, right? So depth first search or the we can say depth DFS. So DFS is an important tool in artificial intelligence because it helps to explore the solutions in a logical and effective way, right? Whether it uses to planning, use it in planning, solving puzzles, and analyzing data structures. DFS helps AI systems make better decisions by exploring paths deeply before trying others. It's not just about the theory, right? DFS not just about the theory in AI. So DFS also helps in real life AI systems like navigations, game solving, or decision trees. So what is first the depth first search again? So depth first search is a traversing algorithm used in tree and graphs like data structure. In generally starts by exploring the deepest node in the frontier, right? So in this part, we can say that DFS used to go through the data that looks like a tree, right? Or a network. It starts from the top or a starting point and goes through a far down one path as possible before trying to other options, right? So imagine you solve a maze, right? DFS is like a choosing a one path and walking all the ways until you hit the dead end, right? When you hit the dead end, you backtrack it. If you do, you go back and try it the next path. If you enter in a dead end path, we come back and we move to our next route. So starting at the root node, the algorithm processes to search to the deepest level of the searched three until nodes with no successor or reached. So you being at the main starting point called the root, then keep the exploring deeper levels like going down a staircase like until there are no more stairs to go down, right? So suppose the nodes with unexpected successor in the encountered them, then the search backtracks to the next deepest node to explore the alternative paths. Like we can say that if you reach a point where whether there are no more options to move forward or to explore the next nodes, DFF will go back one step and it reach to the parent state and try another unexplored path. This is called backtracking. It's like playing a game whether you try to different moves in one path does not lead to win and you go back and try it in a different moves, right? So depth first search DFS explores a graph by selecting a path and traveling it as deeply as possible before backtracking. So DFS always goes deep first. It flows one route all the way before going back and checking the others, right? That is a key idea to go the depth before depth the wild. So we can say that depth first search is a, like a deep explorer, right? It keeps going forward until it cannot anymore, right? Until up to dead end, and there is it turns back to try other way. If it is unsuccessful, if it is useful in AI to explore big decisions trees, solving puzzles, or find solutions in a large data space efficiently. While it's fast and use less memory, it may not be always use the shortest paths, right? So, but it also a strongest base in for many AI strategies. So we can see here how the DFS works. So we selected a graph nodes. We have the nodes has A, B, C, D, E, F, G nodes up to A to G. We have nodes. We selected starting point as A, has a parent. Sorry, has a parent a root node. We selected root node as A. We traveled from A. Then we have two paths. We can move either we can move B or C. we selected to move B, right? Which we choose. And we can choose any nearest part to. We don't need to move after letter A, we want to move B. After letter A, we want to, after B, we want to move C. Not like that. It select the straightforward way. First, it want in BFS, in bed search, we move level by level, like order to order, level by level. But in DFS, there is no need to follow the level by level. It goes across the until because we have a backtracking system in this DFS, so we can move anywhere and come back to the parent node again. We can do just one thing we want to keep in mind that we did not form any loop circle here. We did not want to close the node. We did not form any circle while we travel tracking the other nodes. So here it takes B. So at the B we want to find D and E. Let's compare to D. We come the next node to the D and we visited D, and for the next node we visited E, right? So after D we have no nodes. We go track back to B and we comes to the D. After E also there is no track back, right? So what we do additionally right now, we track back again to the C, because how after BE we did not have any nodes. So we track back to our parent node A, B, sorry, B, our B parent node is E. So after we track back directly, we jumps into the next track back. So we let's enter into the C. Now after C to F, so this is the final output. We reach at the G. So like the system works. We can see here DFS. So we starts with we here also we have one, two, three, four, five numbers. So we start with one and we move next node to the two. Next we move to five. We can have the dot y because whenever you started a flow, like we are moving it straight forward, because it reach up to the depth of the line. Okay, so there is no need to we want to first select five and we want to go three, then after we want to go four, we want to two, had two, after three completion, we want to track back and two. So it's a long process. Whenever you start, the node will started, it reach up to the dead end, right? How many length? If we are four have, if after the four we have six, after six we have eight, like it moves so forward, right? So when it comes to the 4, 7, 8 like that, so we can move up to directly we leave the 5 and we directly move to the 6, 7, 8 like that after 4. So depth first such meaning is to reach the depth tree, right? So after that we move to the 1 to direct 4. We reach the dead end of the graph nodes. So after 4 we doesn't have any root nodes, right? We track back again to 2 and we go for the 5. Again we track back to the 2, track back to the 1, track back to the 1, right here. So like the system works like here. So when it starts with 1, right? So it starts with 1. It comes to the 2. So it starts from 1. It's come to 2 and again it track back to 2 and again it's come to the 3, sorry, here it come, here it's come to the 5, again it track back to the 2, again it track back to the 1, again it reaches to the 3. It's always find a route, okay? So it's finding like this, moving this like this it reached, right? So we didn't form any loop here, right? All this like it's works. So DFA up to it reach the depth of the light. Here we have up to deadline. It moves up to dead and it reaches. So key characteristics of DFS. We can say in simple terms, the DFS algorithm in AI holds the power of the extending the current path as deeply as possible before the considering the other options, right? So DFA algorithms hold the powerful extending because it has to reach the depth of the tree, right? So how many possible chances to take the depth? It will be take the options to take the possibility. If there is no option, to track back. So DFS is not cost optimal sense. It does not grant it to find the shortest path, right? So it does not it does it necessary to find the shortest path, shortest distance for wherever the node starts until it reaches the dead of the node. So DFS uses the simple principles to keep track and of visited nodes. Yes, it uses the simple principles. Or like we have to find the shore nearest path like that. We doesn't find and it's simple principles like it use backtracks like keep tracks of the all visits. It visit up to the each and every node of the graph. It use the variant of the DFS is called backtracking, such which they use less memory than traditional depth first search, rather than the generating all the successor. Right, the backtracking search enables the DFS to generate only one successor at a time. Right, whenever we reach the dead end of the node, we simply backtrack. Right, so this is the most useful thing in DFS. So because we don't first form we easily complete all the nodes. It saves the time compatibility. It saves the reduce the um, searching process like that. So in this we have uh, edge cases in depth search tree based on spanning tree. So we have forward edges, back edges, tree edges, and cross edges, right? So for the forward edges, the forward edge is the responsible for the pointing for one node of the tree to one of its successor, right? So in back edge, right, the back edge holds the power of directly its edge from the a node of the tree to one of the its um, ancestors, right? So tree edges, when DFS explores the new vertex from the current vertex, the edge connecting them is called tree edge, right? So it is the initial while constructing of DFS spanning tree because it is represent the path to be followed during the travelers, right? So spanning, we know the spanning tree rule. It does not form any loop or circle. So it follows the with connecting the while by connecting the edges. It does not. It checks the path wherever we doesn't want to form circle like that. So always it's checking whenever you're driving one vertex to next node. It always checks the edges. We didn't if the edge is forming loop or not. So cross edges like cross edge or the edge that connects two vertices or neither axiom, sorry, ancestors or nor descendant of the each other in the DFS tree. So we can see here the forward edge, backward edge, like we can see the cross edge of the distance between the forward edge, nothing but whenever we completed here, like whenever we come to A to C, A to D, A to G, so we directly backtrack, right? So we can see forward edge, like we can directly jump to G like the how like example I can say like that if we visit A to B, right, and B to D and D to E, and we want to go directly A and C, right, we want to go A. So what we did here, we directly backtrack to B parent node. Okay, directly if you can backtrack to A, right. Forward means if you are already completed C and D F, right, we completed F, so we want to move to G. So we can directly use forward edge to directly G like that. Cross edge means between the two nodes relation, how much distance you can easily track back or not. Cross edge is if it form the cross edge, it will form a loop here like that. So I hope you guys all are understand about the DFS. Thank you all.